So, been working with Terraform for a little time here, and so I wanted to cover my thoughts on the state file and how you could manage it and everything. And the docs for that are actually right here under docs and under state file and under approaches here. So it says Terraform state file approaches and thoughts. And these are just actually my summarized thoughts of this presentation right here, evolving your state form with Terraform. Is a really good presentation there. And I just kind of put in my own words and kind of try to validate and explain why I think people eventually evolve to approach number 3 and 4 essentially here. Okay, so it always starts like this, one state file for everything. And I did it myself when I was starting to work on Terraform. And the reason why people take this approach initially is because it's simple, right? You don't have to think about an additional thing that you have to figure out when you're just trying to learn Terraform itself, right? Which is already like going to be some work. So people take the one state file approach for everything, and I call that the pile of mud approach, or the garbage can approach. Basically, whatever you create, you're just throwing one big state file. So one of the issues with this is there's no separation between like development environments and production environments. They're all munged together. So because there's no security boundary there, somebody who's, let's say, new is trying to just deploy a resource onto development, oops, accidentally affects the production environment and deletes something off production. So this does happen, unfortunately. So you can actually prevent that from happening by not putting everything in one dog pile right there. Okay. The other kind of issue is speed. So with the one big monolithic state file for everything approach is the way Terraform works is it evaluates what resources out there are in cloud already by making API calls. So let's say you have one big state file for everything and you have 1,000 instances. It's going to make an API call to, figure out how those 1,000 instances are configured. That's going to be slow no matter what. Even with the parallelization, you're probably hit to rate limits. So I see issues on GitHub saying, oh, Terraform is slow. Well, maybe it's because you have a monolithic state file, right? So that's just the nature of the beast. So I think it's pretty obvious that you shouldn't put all your state file information into one big old state file. So what happens is people then evolve their approach to a state file for each environment, like a state file for development, a state file for production. And immediately we get a pretty big win. The big win is we separate production from development. You apply something on development, you cannot affect production. So that's really a great win right there. But the issue with this still is there's no distinction within the environment of whether or not a specific resource is mission critical. For example, the network or the VPC. So you usually don't make a lot of changes to that often. And when you do make a change to that, you gotta be very careful. You gotta know what you're kind of doing. All right. So again, let's go back to, let's say, a new developer. He just wants to deploy a EC2 instance, okay? And he deploys the EC2 instance, and oops, he affected the network. It's not really kind of his fault here. It's just the way it was decided on how to manage the state file. And again, people do this because it's easy and you're just kind of getting started. But eventually, you're going to have to pay for it. Eventually, you're going to have to figure out, okay, I need to evolve this state file and I need to go take the next approach. And guess what you're going to have to do? You're going to have to do the port. You're going to do the migration. So it's better, I think, if you use some of these lessons learned and just go right off the bat with maybe an approach that will make your life a little easier. Okay. And that approach is essentially number 3 and 4. And there's only a kind of distinction here between 3 and 4 here in the really kind of TerraSpace land, because TerraSpace makes a distinction between modules and stacks. Basically, stacks or modules are meant to be deployed, and modules themselves are just kind of reusable functions or reusable internal modules, really. But anyway, 3 and 4 is essentially the same, where what you're going to do is deploy a state file or use a state file for kind of a group of modules that logically make sense to deploy, or essentially a stack, okay? So you can deploy like a network stack or a database stack or compute stack here, like EC2 instance. So if there's a state file only for the EC2 instance, we know that we can only affect the EC2 instance, okay, on production, or the EC2 instance on development, right? It's scope to environment. So, and the network stack is completely separate in terms of state file management. So these two can't cross boundaries. They can't affect each other. So this is the approach that people eventually evolve their Terraform state file approach to. Usually after, again, some pain and suffering from going to 1, 2, and then they go, oh, I should have done 3. So this is actually the default setting that TerraSpace uses, just because, again, have gone through this pain myself already, and so this is the reason why I think actually having a separate state file per stack that you're deploying makes complete sense. And this is actually the approach I would recommend. And this is, again, just kind of based on not just my approach, but other people's approach too. And this is just kind of my thoughts on this subject, because this conversation still comes up over and over and over again. And so I just wanted to kind of cover this and explain why TerraSpace kind of took this approach, and why this approach makes, I think, a lot of sense. So hopefully you found that helpful. Thanks.